Welcome to this episode of Robert's Creative Chronicles. Today we'll be solving this question. It states form a differential equation by eliminating the arbitrary constants in the following A and B. So A states that y is equal to a cos x plus 3. B is y squared is equal to 4a in bracket x plus a. So let's start. So this will be our equation 1. Then we'll differentiate this equation. Now, this equation is a function of a function. The first function is cos, the second function is x plus 3, which is in bracket. So we'll differentiate it using a function of a function formula. We'll first differentiate the internal function and then multiply it by the derivative of the outside function. So the derivative of the inside function x plus 3 is x is 1 because the derivative of x is 1 and the derivative of 3 is 0. So the derivative of the outside function is 1, of the inside function is 1, multiplied by a. So the derivative of cos is negative, minus sine x plus 2. So which is equal to minus a sine x plus 2. No, dy over dx is equals to minus a sine x plus 2. So this is our second equation. Now we'll differentiate it for the second time. The square y over the x square is equal to, now using the same way we did this, derivative of a function, we'll differentiate the internal function is 1. The outside function sine, derivative of sine is cos, it will be minus a cos x plus 2. So this will be our third equation. So you can see that y from the first and third equation we have a common term, a cos in bracket x plus 3. So we will substitute equation 1 into 3 so that we'll get the differential equation, because the differential equation is an equation that contains x, y, dy dx, and only dy dx terms. So it contains x, y, dy dx, and terms. It doesn't contain all these constants like a or b. It only has this x, y, dy, and the x terms. So that's why I want to establish this equation, an equation, a differential from this. So when we substitute equation 1 into equation 3, we will get here, this one is y from here. So it will become the square y over the x square is equals to minus y. You can take this to the other side to get the square y over the x square plus y is equals to 0. Now, this is our differential equation. So this, we have successfully expressed this term in this form. So this is the differential equation by eliminating this constant a. So the next one we are going to do is b part. So here's the b part. Now, this is our equation 1. Now, we'll differentiate this equation. You know that this y square now, the derivative of y square is 2y, but we have to add the y over the x because we are differentiating y. This is an implicit differentiation now. Because of this y, to differentiate y, you have to add the y dx to it because the derivative is derivative of y with respect to x. So only when you are differentiating x, you don't add the y dx. But since we are differentiating y, you have to add the y dx. And now this is known as implicit differentiation. So now this one, so we have to open this bracket before we can differentiate it. So if we open this to be 4ax, the derivative of 4ax is what? Derivative of 4ax is 4a. Then 4a square, the derivative of 4a square. Since 4a square is a constant, the derivative is 0. It will be plus 0. So 2y over the x equals to 4a. Now let's express a as the subject of the formula. To express a as the subject of the formula, we'll bring this here, so it will become 2y over 4 y over the x equals to a. So now here this one becomes y dy over 2dx equals to a. So this becomes our second equation. Now, what we will do to get our differential equation, you see, here is a, here is a differential equation term, x is also a differential equation term. The only non-differential equation term is a here, and we have found a differential expression for a. So we'll simply substitute this into this to get our differential equation. So it will be substitute equation 2 into 1. So let's do this. It will be y square is equal to 4. Let's open the bracket first. 4ax plus 4a square. You see, 4ax plus 4a square. Now let's substitute this. What's my a? A is y over 2 dy dx x plus 4 y over 2 dy over dx all squared. So open the bracket. What will we get? This 4 will divide by 2, so it will become what? 2y over dx, and there's also an x here, plus this one will square it to become 4. If you square these 2, it will become 4, so it will come outside, become 4. So now this one will become y square, right? Then y square times dy over dx square. Yes. So y square equals to 2xy. Bring this x here. Dy over dx plus y square dy over the x square. So now let's move this to the other side. To move this to the other side, this will come here. Oh no, let's bring this one here to make things easy. So we'll just bring this y square here to become y. Though it's also correct, you can also leave it like this. But since it's an equation, most of the time an equation is always equated to 0. But any form you leave it is also correct. Even this form is correct. So y square dy over dx square plus 2xy y over dx minus y square equal to 0. So here is our final answer for the B part. I hope you understood how to find the differential equation of by eliminating constants from an equation. If you have any question, you can ask me in the comment section, or you can also ask me through my WhatsApp or email written in the description below. Thank you for watching. Please don't forget to like, share, and subscribe to my channel and hit the notification bell to get notified as soon as I upload a new video. Thanks.